This is lecture 203, continuing 2D drawing in Rhino, and an introduction to 3D modeling in Rhino. In this exercise, we're going to take this floor plan that we were working on last class, and we're going to transform it into a 3D object. And there's a few commands that we're going to work with today that I think are important. I told you guys I would let you know, these are kind of the takeaway skills that I want you to have by the end of the day today. The first one is rotate 3D. We're going to work through how to rotate objects in 3 dimensions. I think that will help a great deal. And then the other kind of key command that we're going to work with today is a command called project, which you will use. It's invaluable, but it's a little tricky at first to kind of get used to how it works. So I'm going to walk you through those two and a bunch of other ones, but those are the kind of the takeaway ones that I want you to be comfortable with. So I went ahead and I opened my exercise 202 from last class, did a save as to make it exercise 203. So we're going to do a little bit more two-dimensional drawing, and then we'll get to three-dimensional drawing or three-dimensional extrusions and that sort of thing. And what I want to point out here is that we can work just like we do in AutoCAD to draw the building's elevation. And I'm not expecting a really fancy elevation. We don't have to deal with roof lines and that sort of thing. Actually, you would probably build those in 3D anyway. But when it comes to figuring out where the windows are, sometimes doing a quick little elevation drawing can help you a great deal. So I'm going to work in very generic terms for right now. I'm going to start with my polyline tool, and I'm going to reference my building itself. Now, I'm not currently snapping to anything because my object snaps are not turned on. So down below here, I'm going to check end, mid, and perpendicular. Those are the 3 that I tend to leave on permanently. And now when I come over to this corner, I can snap to that particular corner. I can also use my smart tracking to come down here a ways. It doesn't matter how far I'm coming down here in this sense. I just want to be in a line. And then as I continue, I'm going to smart track from that point, pull down, and it's going to, because I have perpendicular snap checked, it's going to snap to being perpendicular. So there it is, nice and perpendicular. And I have the first part of that line. This line would continue on to do that building there as well, but I'm going to stop it right here for right now. And then I'll do a separate line that goes from here to that end right there. And so I have this line and I have this line representing this wall and this wall. Now at this point, I'm going to go ahead and draw the rest of this little wall. Let's assume for the moment that's an 8-foot tall wall. I can draw up here 8 feet. I can draw over. And again, I can use my smart tracking and my snap to perpendicular to draw to right there. And so I now have between this and this, I have this wall drawn. And I can also continue on from right here, and I can draw that wall here. So this and this line would represent this wall right here. So I'm just drawing the building's elevation. Next thing I need are my windows right here and right here. I'm going to go ahead and pull down 2 lines. I'll just snap to my window and pull all the way down to perpendicular. Same thing. Pull all the way down to perpendicular. And now I have 2 guides for where this window would show up. I need to know the distance off the floor and also the distance from the ceiling, or how big the window would be. Again, all of this is completely made up, so you can make it whatever you want. It doesn't really matter to me. It's just the act of creating this is the important part. So let's say that this window is 3 feet off the ground, so I'll use my smart tracking to go to 3 feet. And there it is. I could, oops, sorry, I didn't press enter. That's my fault. Not 3 inches. Can't type this morning apparently. How about 3 feet? There we go. Enter. And I could offset this. So I could do an offset for whatever I wanted my distance to be. Let's say it was 4 feet. There it is. I could do it that way. Alternatively, I could measure down from above and draw another line. Again, it doesn't really matter for our purposes. So at this point, I have this line, and these 2 lines are way too big. You can see them there. I'm going to use that fillet tool, the one that I used last class, and I'm doing these kinds of things to just kind of remind you. I could use trim. That would be one way of doing it. I'll trim the bottoms and I'll fillet the top so you can see both methods. The fillet tool, which is available under curve, and then fillet curves right there, or you could type in fillet. I'm going to set my radius at 0, not 1. Oops, there we go. And when I select the first curve, I would select this curve followed by that curve, and it makes a nice 90-degree corner for me. And again, that's because my radius is set to 0. So I can repeat that command by right-clicking, and then I could do it there, and that forms a nice 90-degree curve. Alternatively, I could use the trim command. I can access that by typing trim, or I can go to the toolbar here and pick the trim command. It's also available under Edit and then Trim, or I could press Control-T. So lots of ways of accessing that command. First thing it asks for is to select the cutting objects. My cutting object would be this line in this instance. I'll go ahead and press Enter, and then I can get rid of this line and that line there. I'll go ahead and press Enter to finish. Now this is still made up of 4 separate lines. So I may want to make those one line, and actually it's a lot easier down the road if I do it now. So I will select all 4 of those. I'm selecting from left to right this time and completely containing. Remember, right to left selects everything it touches. Left to right is only what's completely contained within the rectangle. And then I'll go up to Edit and go to Join. I could also press Control-J or type Join into the command line. That then takes those 4 separate curves and joins them into one polyline for us. So that represents my first window right there. I'm going to create the second window, and I can do this. This is again a little bit of review from last class. I can take this window. I know there's 6 inches between the windows, so I can use my smart tracking while I copy to make the second version of this window. So I'll go up to Transform and then Copy. Alternatively, I could type Copy into the command line. I will hover my mouse over this corner right here, move to the left without clicking, and go ahead and type 6 inches. That gives me my distance, and then I can snap to that corner of the window right there to create my second window. Now I'm not going into full detail here. I don't need full windows, I don't need trim, I don't need any of that. We'll get to that kind of detail later on, but for our purposes, I really just need the hole in the wall. That's where the window is going to be, that's the hole. So I'm going to do the same thing over here. I actually don't have my windows drawn just yet, so let me really quickly draw in those windows. Let's center it on the outside wall here, and let's move from there over by 3 inches. That would be my first window. Let me do an offset now. And we'll offset by 6 inches. There's that. We'll repeat the offset, so I'll right click, and this time my distance, I think it said it was 4 feet. And we'll do that, and we'll do right there. So I just created those little windows there, and I can do the same thing down below here to create the second round of windows. So I could start by snapping here and coming all the way down to perpendicular. Same thing, line or polyline from that corner all the way down to perpendicular. If they had the same sill height, I could come straight across and draw there. Alternatively, I could smart track from the bottom. Say it had a different sill height. Let's say it was 2 feet. There it is. And then I want this window to be a little bit taller, so let me offset by, I don't know, 5 feet. Something like that. Then I could do my fillet. Again, my radius is set to 0, from there to there, and from there to there. Alternatively, I could trim, pick the trim tool, select that line as my cutting object, and then get rid of those 2 pieces. I'll press Enter to finish. Last thing I'll do is select the whole window and go up to Edit, Join. Alternatively, I could type Join into the command line to do that as well. The other option here would be to take an existing window and to copy it over. So let me go ahead and go to Transform and then Copy, and we'll drop it to right there. This window here is obviously not the right size. So Rhino does allow us to do the same thing that AutoCAD does when you stretch an object. Rhino allows us to do it, but they call it something different. It's called Scale 1D. So if I go up to Transform and then Scale, I have 3 scale options, and we'll cover this in more depth later on. I have scale 1D, 2D, and 3D. These are the 3 different ways of scaling. 1D is scaling only in one direction, so that's what I want to work with. So if I scale in 1D, I would say from here to here, I now want that to become a new measurement. So in this case, it was 4 feet. I can repeat the scale 1D, and my height, I want that to become the same as that. It's just another way of doing it. And it's based on what you find easiest. So at this point, I have kind of the basic framework of what this wall looks like, or this wall and this wall. And I'm now going to take this and start to work in 3 dimensions. So I've gotten through part 1. We're going to work on part 2 next. So I'm going to double click on the top view label here so that I can look at this in perspective. And I'll double click on the perspective view. And that lets me see the whole piece that I've drawn so far. Remember, I can right click to orbit so that I can move around my objects to see them kind of in 3 dimensions. So thus far, everything's perfectly flat for what we're working with. So before we start to create the 3-dimensional objects, it's time to revisit the layers. So over on the right side, there's a little icon that looks like a piece of pie. It's like an American red, white, and blue piece of pie. You're going to click on that. And I like to drag it over and make it a little bit bigger so we get a little bit more showing here. And if we look at that, we now have our layers palette open. We have a default layer, and then we have layer 2, 3, I guess 6 and 7 for me. Yours might be 1, 2, 3, 4. I don't know. I don't know why mine says 2, 3, 6, and 7. But those are the default layers that are available here for me. Everything that I've drawn so far is available on the default layer. So the rest of these layers, if I were to click the little light bulb icon, nothing would happen because there's no content on those layers right now. So given that this is my default layer, I'm going to rename that default, instead of being default, to be floor plan. So I'll go ahead and double click on the name itself and type in floor plan. So there's a floor plan layer. The elevation that I just drew is currently on the floor plan layer. So let's move that elevation to be over on layer 2. And in fact, I could rename layer 2 before I do it to be elevation. So let me select it and type elevation. So to move layers in Rhino, first thing I need to do is to select the objects that I want to move layers. Now, sometimes this involves some orbiting. So if I tried to select it this way, no matter how carefully I try to select it, I'm going to end up selecting other parts. So get used to orbiting a little bit and then choosing your selection in the orbit. So I've rotated or I've orbited my whole workspace so that I can make that selection easy. Once the elevation is selected, I'm going to come over to the layer palette. I'll right-click on the word elevation, and I'll say Change Object Layer. And that then changes this to be on the elevation layer. If I want to see it visually that it's on a different layer, I could change the layer color. Currently all mine are black, but I could change, say, this one to be red, and then you'd see it a little bit easier that it's on its own layer. A couple things to be careful of on the layer colors, however, is that you want to make sure that you don't ever use yellow. It's available for you. You could pick yellow, but the problem is if I pick yellow, I can't determine whether that object is selected or unselected because yellow is used for the selection. So stay away from yellow. Any of the rest of the colors are just fine. So I tend to pick red instead. And there we go. Now we can tell which one's selected and which one's not. Okay, so under layer 3 over here, I'm going to go ahead and change layer 3 to be, let's call it walls. So I've double-clicked on it and called it walls. I'm going to make this walls layer the active layer. So I'm going to click right here in this column so that the check mark moves from the floor plan layer down to the walls layer. I have layer 6 and layer 7 here. You guys might have layer 3 and layer 4. I don't need those layers, so I can actually select them and then press the delete key. And once again, I can press that delete button, to get rid of those extra layers. No reason to have the extra layers sitting there. One other thing I'll point out about the layers palette that's different than AutoCAD or pretty much any other program that you've worked with, Rhino has nested layers. So I could actually create a new layer, and I'll click on the new layer button here. I could call this 2D drawing, and then I could take the floor plan and the elevation. I can hold down Shift to select them both, and I could drag them onto the 2D drawing layer, and they then become sublayers of the 2D drawing layer. This helps a great deal in Rhino because by the time you get to your final project, you're probably going to have 100 to 200 different layers as you bring in objects and whatever. So nesting your layers really makes a big difference. It makes it easy to quickly turn on and turn off. So in this scenario, the 2D drawing layer allows me to turn off all the 2D drawing, but it also allows me through the sublayers to turn off individual drawings as well. So it's kind of beneficial. As we go through, a couple other things to note in the layers palette. We have the ability to lock objects. So I could, for example, lock all of the 2D drawings, and then I can't select them. I can still snap to them. So if I use my polyline tool, I can still snap to them, but I can't actually manipulate or select them or delete them or whatever. So be aware that that lock icon is there for your benefit. Okay, so the walls layer is current. It's time to start actually building out my walls. And so we're going to build our first little bit of 3D in this particular assignment. Oh, looks like I did. Sorry. I was going to do part 4 instead of part 3. These kinds of things are interchangeable, so let me go in the order of your exercise just so I'm consistent. I'm going to do rotate 3D first. So what we want to do is we want to take this flat drawing that I just did, this elevation drawing right here, and we want to rotate that up so it's standing in the 3rd dimension instead of laying flat on the ground. And we're going to do that using the rotate 3D command. So if I go up to transform, and then you'll see that there is rotate and there's rotate 3D. A regular rotate is essentially, let me take this object, sorry, there it is. I'll pick a point around which to rotate, and then I can rotate that object around in a circle. That's staying flat. So I'm not doing any 3-dimensional rotation to it. What a rotate 3D does, when I pick it, is it allows us to rotate in the 3rd dimension. So first thing the command line says when I choose rotate 3D is to select the objects to rotate. So let me orbit a bit and select those objects. I'll press enter when I'm done. There we go. Next thing it says start of rotation axis. So this is the line around which you want to be rotating. So you can choose what this line is. In this case, I want to be able to stand up this wall so that it's vertical instead of horizontal. And I'm going to do that along the base of this wall, which is right here. So the line or the axis around which I want to rotate would start here and would end there. So it's the bottom of the wall. And as soon as you do that, you then get a little guide with a circle showing you which direction you're going to rotate. So at this point, my reference would be the wall itself, and I want to pull that up until it's standing perfectly upright. I can hold down Shift, and it's going to jump to 90 degrees for me. Otherwise, it's hard to tell where straight up and down really is. So I'll hold down Shift and then click there to have it standing up. I'm going to do that again. So once again, I'll go up to Transform and then Rotate 3D. I need to select my objects first. So there are my objects. Whoops, didn't quite get them all. There we go. I'll press Enter on the keyboard to select those objects. Next thing I need to determine is the rotation axis. So the rotation axis is the bottom of this wall. And so I would go from here to there. And then my reference point would be the length of the wall itself. And I'm going to pull that up until it stands perfectly vertical. I'm holding down Shift to make sure I get to that perfectly vertical right there. The big mistake people make with the Rotate 3D is they pick the wrong axis. So instead of picking from here to here, they pick this axis, and then all of a sudden they're rotating this direction. So it's really about thinking around the line that you want to do your rotation, or what is the bottom of the wall in this case. So that would be the bottom of the wall, and I'll pull it up till it is standing up vertically. So now I have that elevation, and we're good. Time to make some three-dimensional walls. So when we get to making the three-dimensional walls, this is part 4, we're going to be doing the extrude command. Some of you have walls that are completely joined. So like this one here, it's joined across that door. We come around here and it's joined to that door there. If I select this one, likewise, it's completely joined all the way around. Some of you will have walls that are not completely joined, or that might be partially joined. So it might be like this, where those two are joined, but they don't connect to these pieces. You want to make sure, and before you do the extrude, make sure that your wall is completely joined and it is a closed curve, not an open curve. And I'll show you where some mistakes tend to happen. So I'll take all of the objects themselves, so there, and I'll come over here to those objects, and then I'll go ahead and type join. And in the command line here, it'll say 8 curves joined into one closed curve. That's what I'm looking for. Where people sometimes run into trouble okay, so I have this line here, I have a line here, maybe I have 2 lines on top of each other right there, and I take this and I take, oh, you know what, I'm going to have to shorten one of these. Sorry, I have to purposely mess this up. Like this. There we go. So I'll take this and I'll take that piece and I'll join it. And then I'll take this piece and I'll join it to that piece. And now when I did the join, it says 2 curves joined into one open curve. And that's because as I come around here, even though when I select it, it looks like it's continuous, this line here goes all the way through, and this line back here comes back to there. So they don't actually close. When I do the extrude on this, and actually I'll do the extrude over here and then I'll come back to that error so you can see what happens. So on the extrude, I'm going to select my nice closed joined curve, and I'm going to use the extrude curve command. So I'll go up to surface and then extrude curve straight. So right there, it's under surface, extrude curve straight. The key command for it is extrude CRV for curve. It's going to ask me to select curves to extrude. So I would pick that as my curve to extrude. I'll press enter when I'm done. Then it's going to ask me for the height. But let's pay attention to a couple options here as we come here. We've got direction. We've got both sides. If we wanted to extrude both ways, in this case we don't, but you could. Solid. Do I want it to be no or yes? We're creating a wall, so yes, I do want it to be solid, so I'm going to change this option to yes. It's going to put a top and a bottom on my extrusion. That's another place people make mistakes. They do the extrusion, but they don't put the top and the bottom, and then you have to go back and add it. Delete input. This is another one. By default, it's set to no, and essentially what it's saying is, do you want the original curve that you're extruding from to be deleted, so that you end up with just the surfaces, or do you want to keep that original curve? For right now, we're going to leave it set to no, but as you get more and more proficient in Rhino, you'll start to use yes because you don't need the original curve anymore. Okay? The rest of our options are fine by default, so what I need is the extrusion distance. So I need to type in that value. That value is 8 feet, so I'll type in 8 followed by the apostrophe and then enter, and it then creates my solid walls. Now for me, it's showing. For you, you might be seeing this. You see just the wireframe? That's just the view that we're looking in here. So if you're seeing this, come up to the little triangle by perspective and switch from wireframe mode to shaded mode, and it'll give us a preview of what those surfaces are looking like. Okay, so let's come back to this one. Remember, this is the one that I deliberately messed up on. When I go to do the extrusion here, I'm going to go up to surface, extrude curve straight, same thing. I get this error. Curve selected to extrude includes self-intersecting curves. That means that 2 curves overlap each other. So that's a problem. Do you want to extrude the curves anyway? So let's say you said, yes, I want to extrude those curves anyway. And I can go ahead and, again, I can say I want it to be solid, and I want it to snap to this edge. Now when I come around to this side, there's actually 2 surfaces right on top of each other. There's that, and there's this. So it created that extra little piece for me. That's where we get things that don't play nice. So I'm going to go ahead and delete those. I'll come back in here. I'm going to explode my curves, and I'll deselect that extra piece. Let me rejoin those together. Let me select that curve. We'll delete it. And I'll come back in here and join this together. So Control J, for example, will do it. 2 curves joined into 1 closed curve. Perfect. Now we can come back to that extrusion. So I'll go back up to my surface, extrude curve straight. I can snap to my height, or I could actually type in 8 feet. Oops. See, there's an example of a non-solid extrusion. So I can look down inside. I don't want that. So we'll just repeat that extrude. There it is. Make sure that solid is set to yes. And we'll snap right there to get that. So I now have my walls having been extruded. And I have my elevation view over here. So what I'd really like is I'd like for these windows here to be on this wall. Yeah, question? To unjoin? Explode. Explode. So I'd like for these windows that I drew on the elevation to be on this particular wall. So what I could do is I could take this elevation, there it is, let me adjust my selection group here. I could take that elevation and I could actually just move it over to where it sits right on the wall like that. I could do that. But there's a command that's built into Rhino that will do that for you, and it works really nice when you don't have a nice flat surface. So if you have something that undulates or a complicated surface, you can do the same thing. So in this scenario, I want these objects to essentially be thrown perpendicular until they intersect this wall. And to do that, it's a command called project. So it's kind of like if you have a projector and you put something in front of it and it shines on a wall. We're doing the same thing here. So to do that, though, I need to see all 4 views at once to set this one up. So I'm going to double-click on perspective so that I'm seeing all 4 of the views. I'm seeing the front elevation, and I'm seeing the right side elevation. So in this scenario, you can see that is my elevation view. There it is obviously here, and there it is in perspective. So when I start with it, and I go to the project command, it's going to be curve from objects, project. Alternatively, you could type project into the command line here. It's going to say select curves and points to project. So it doesn't matter which view I do this in at this point, but I'll select my curves. There they are. It was easiest for me to do it in the right view. One other strategy that might be useful is you can actually go to the layer and you can right-click and say select objects. And that will pick the objects that are on that layer. So if it's only the objects on that layer. So different ways of selecting. So I have that selected. I'm going to go ahead and press enter when done. Perfect. Then it says select surfaces and polysurfaces to project onto. Now this, which view you select in, really matters. So if I did it in the perspective view, it's going to try to throw these objects perpendicular in the perspective view and intersect. That's not going to show up on the wall, if it even hits the wall, where I want it to be. So I need to do this in the view that is perpendicular to the direction I want to push these windows. So in this case, it would be the front view. So I'm going to make sure that front view is highlighted and active. Then I'll choose the surface that I want to project onto. So there's that first surface. And you see it selected in the other views. But I'm making the selection in the front view. That's the key part. Once I'm done, I'll go ahead and press enter. And those windows will show up right there. And they actually project all the way through to the back side right there. So let me do that one more time so you can see it. So again, I'm seeing all the views. I'll type project to start. Select curves and points to project. I'll just go ahead and make the selection in the right view. That doesn't matter. The next one is where it matters. I'll press enter. Next one is select surfaces, polysurfaces, and meshes. I have to make that selection in the front view. So I make front view active, and then I select the object itself. And then I can go ahead and press enter, and it'll do those curves for me. If I make a mistake, and I do project, and I pick again, I pick my objects, but I'm up here and I say, oh, I want them to be in the perspective view, right there. When I press enter, it's not going to do anything, and I'm going to get this error. The projection missed the selected objects. So that's where what view you're in really matters. So I need to make sure that it's done in the front view. So one more time, project, select my objects. In the front view, I want to project onto this, or excuse me, this one. And ultimately, I'll do the project onto that, and I might as well do it in the same projection. And we'll go ahead and press enter. And now if I look in the perspective view, I have my windows on all those surfaces. So it's pretty convenient. It goes all the way through all the surfaces. Now this little piece here was interrupted by the doorway, so I only got part of a window. So in that case, I'll select it and just press the delete key because it wasn't relevant. Likewise, I didn't have the window that was over here on my plan, so I could take those two windows right there, and I could use my mirror tools. So once again, I'll go to transform and mirror. We'll snap to that midpoint there, and I could put those two windows over here. Alternatively, I could draw the other elevation and project it the opposite direction. Or I could draw this elevation and project it that way. So I have a lot of flexibility. It's just a matter of drawing and then projecting. So from here, I'd like for these to be open so that they're actual windows, not just rectangles projected on the surface. So I have a couple different options for doing this. The first one is using a command called make hole. And I think it's a great command, and it works pretty well most of the time. Every once in a while, you get a window that won't work. But it's easy, and it works most of the time. So I would encourage you to do that. It's available under the Boolean options. So if you see over here in your toolbar, there's two spheres that are kind of glued together. If you click the arrow below them, you'll see that there's a bunch of Boolean operations. This is essentially take these pieces and add them together, take these pieces and subtract, that kind of thing. And if we come all the way down here, there's actually a make hole tool right there. So kind of a white line and a wall behind it with a hole in it. So if I click on that, it's going to select, say first, select planar closed curves. So that's key. So a planar closed curve would be this object right here. It's in one plane, and it's closed. It wouldn't work, say if I had this and it was exploded, or I hadn't joined this window together and I did the projection and they were all separate objects. When I go to do the make hole here, and I go to select it, sorry, it won't even let me click on it because it's not a planar closed curve. So I need that, oops, try it one more time. There it is. I need that planar closed curve first. I'll press enter. Select a surface or polysurface. This is where we select the wall itself. There it is. And the next thing is select a depth point. If we want it to go all the way through, we just need to select the back of the wall, or we could press the, or we could type in the distance of the wall. So I could type in 6 inches. It's much easier to snap to the back of the wall. So I'll snap to the back of the wall, and then magically it cuts a hole right through for me. Pretty easy. So in this scenario, I'd have to come back and take these 4 curves there, and right there. I'll go ahead and join them together again. Now they're a planar closed curve. And I can go back to the make hole tool right there. I can select my planar closed curve. Perfect. Enter. Surface or polysurface. There's my surface or polysurface. And then I can specify my thickness of my wall. Now that's cutting all the way through the wall. Alternatively, I could go less. I could say, you know what, I only want it to be 3 inches. And when I do 3 inches here, it's going to ask me which direction, sticking out or going back. I want it going back. And it'll actually create a little niche for me. So I've carved out that section of my wall. So this does not have to be rectangular either. So I can do this in any variety. So if I came over here and I did a fillet, this time we'll set a radius of 1 foot. And I said, okay, let's fillet that, and let's fillet that, for example. This is still a planar closed curve. I can do the same thing. I'll come over here to make hole, right there. My planar closed curve is that right there. I'll press enter, select surface or polysurface. There it is. My depth point is the rear of the wall, and now it cuts that out. So don't feel limited by the fact that it's a rectangle. In fact, you could have any closed planar curve. It could be the shape of a star or whatever it is you want it to be, and you can do the same operation. If the make hole for some reason is not working, that's where we're going to come in and do it manually. So in that scenario, we'd have to use the trim command. So I'd come over here to trim. I'd select my cutting object. It would be this curve on this side, and then I would orbit around and select that curve on that side. So I have both of those curves selected. I'd press enter. Those are my cutting objects. Then I would trim the surface there and there. And I've now cut through and made that hole. I'll press enter to finish. But notice that it's still hollow. So I need to fill in this surface again. So I'll come back and I'll select these two curves again. So there's the first one. I'll hold down Shift and select the second one. There's the second one. With those two selected, I can now go back to my surface and then loft command. We use that on the first day. It's going to ask me where the seam should be. That's fine. I'll go ahead and press enter and say OK. And it's now made the inside of that window for me. So it's a lot more steps than the make hole. The make hole is more efficient. Either way works, and it gets you to the end result. So we'll go ahead and you'll cut the rest of the holes through. On my doorways, I don't actually have the header above the doorway. So I can do that just using the box corner to corner tool. So I could say from here to there, and then I'm just extruding down. I could snap to the same height as the window, right there, for example, to create that little header. Same thing, I could come in here, and I could go from there to there, and I could come down to whatever value that I want. Typically, door height is 6'8", so this would be -1'4" if I was being precise, and that would be it there. This is obviously a little bit taller, so theoretically it'd be a custom door. But again, I don't really care. It's more the act of creating this stuff. So I'd come around here, one more, and we'd fill this one in, there, and we'd come down to the height of the door, and there it would be. And then I'd cut through these pieces as well. So from this point, I'm going to let you guys work and create this. The goal is to create this in 3 dimensions using your Rotate 3D, becoming proficient with that, and then using the project command to basically throw these flat planar curves onto your surfaces. Those are the 2 key takeaways that I want you to be comfortable with today. So make sure you're able to do both of those and feel comfortable with it. When you're done, you're going to create a capture the same way you did last class. So you'll zoom in until you see the view nicely. You'll come up to this little triangle, and you'll come down to Capture to File. That will allow you to save your image. There it is. When I say OK, you'll then save it as a JPEG. You'll click Save, etc. Do make sure that you save your Rhino file. I forgot to mention last class that you should always save your Rhino file. I'll do that by going to File and then Save. So just regular File, Save. It will save a Rhino file for you. If you're doing it for the first time, it will look more like this, where it'll ask you where to save it, and you'll save as type will be Rhino 6 3D model or a 3DM file. All right? That's for the Rhino file. To make the JPEG, you're going to go to this little triangle on your viewport and come down to Capture to File. And that'll save the JPEG that you'll post as the featured image on the course website. On Wednesday, we'll cover the introduction to V-Ray materials. We did a little bit of V-Ray materials on the first day, but we'll do a little bit more in depth next class. We will play with materials, and then we'll end up in here assigning some materials so you can see how the assigning materials works.